Okay, I'm Austin McCall, as you all know, and today I'm going to be teaching you about how the Earth was formed and the structure that it has. First, I'm going to teach you how the Earth was formed. Basically, the most popular theory of how the Earth was formed was the Big Bang Theory, which I explained in detail on my poster. Basically, what scientists believe is there was a gaseous point in the universe, and instantly, for some reason, the pressure was so great in this one gaseous point that it burst, releasing thousands of hot atoms over the entire universe. The hot atoms eventually began to gather together to form gaseous planets like our Saturn and Jupiter. Over time, these planets gain enough pressure that they implode on themselves, releasing more atoms into the atmosphere of space. The atoms that these gaseous planets release eventually come together and form other planets like us. That's basically the Big Bang Theory in a nutshell. Okay. Other major events in the formation of Earth is, I have it on a timeline. 4.6 billion years ago, the Earth was created. These are all just estimates, what scientists believe. 4.5 billion years ago, the Moon was formed. That's not necessarily important to the Earth itself, but it's a major event since we see the Moon every day. 3.8 billion years ago, bacteria arose, signifying life, basically. 3.6 billion years ago, the Earth begins to cool. Because when the Earth was first formed, scientists believe it was basically like Venus is today. It was highly acidic, it was volcanic, and there was no room for life here. But after it began to cool, the water cycle kind of stepped in. 3 billion years ago, clouds formed, signifying evaporation, condensation, and the beginning of the water cycle. 2 billion years ago, eukaryotic cells evolved. Eukaryotic cells are single cells that have a nucleus, basically the simplest form of life. And 0.5 billion years ago, oxygen saturates the Earth, and that's the big thing that allowed life to evolve here instead of on other planets. Okay, now I'm going to teach you about the structure of the Earth. I have it set up like Pac-Man, just because it looks creative. The top part that we all walk on is called the crust. It's the outermost layer of the Earth, and it's about 75 kilometers thick. Just to put in that perspective, I know 75 doesn't seem like a big number, but the deepest holes we have ever dug are 12,262 meters down into the crust. They took 43 years to dig, and yet they only went down less than 1/6 of the entire thickness of the crust. They went down 12,262 meters, whereas the crust itself is 75,000 meters. The next layer is the mantle. It's the thickest layer. It's 2.8 thousand kilometers thick. And it's mainly, the top part is mainly rock, like solid rock, but then the bottom portion of the mantle, which takes up the majority of the mantle, is liquid. And the top part is the solid area is called the lithosphere, and the lower semi-molten portion is called the asthenosphere. The next layer down is called the outer core. It's composed of iron and nickel, and it's basically magma. The inner core is the innermost section of the Earth, and the outer portion is liquid, but the inner portion, which takes up the majority of the inner core, is solid iron and nickel alloy. Okay, sorry, I have more. Okay, the inner core is solid because under such great temperatures, which are estimated to be in excess of 12,632 degrees Fahrenheit, and under pressure of more than 3 million sea level atmospheric pressure, I'm not exactly sure the correct terminology for that unit of measurement, but under such great pressure and heat, it solidifies the metal that would not be solidified in places like the outer core and mantle, because the further you go into the Earth, the greater the pressure. So it solidifies that. And as we can see over here, like I said, the Earth formed 4.6 billion years ago. I know that seems like a long time anyway, but just to put that in perspective, humans have only been around for around 100,000 to 200,000 years, depending on your definition of human. That's basically going back to the theory of evolution, if you count early mammals to be human, or if you count more modern-day Neanderthals, etc., to be human. That is my project.